Hey everyone, and welcome to The Explainer. Today, we're jumping right into a topic that is absolutely on the bleeding edge of tech, AI agents. Now, you've probably been hearing this term pop up everywhere, but what does it really mean? I'll tell you this much. There are a whole lot more than just fancy chatbots, and today we're going to break down exactly what makes them tick. So, here's our game plan. First up, we're going to tackle the big question, what even is an AI agent? Then we'll pop the hood and look at the core components that make it work. After that, we'll explore how these agents can team up on complex jobs. Then comes a really important one. How do we build agents we can actually trust? And we'll wrap it all up by looking at the biggest challenges developers are facing right now. All right, let's get right into it. First things first, we need to get a really clear definition of what an AI agent is, and crucially, how it's different from a regular AI model. It's the question of the hour, right? The key here isn't just about being smart, it's about being active versus being passive. That's the real game changer. Okay, so at its core, every AI agent runs on this simple but really powerful loop. First, it perceives the world around it. It takes in text, images, whatever data it has access to. Then it reasons. This is the thinking part, where it figures out what to do next and makes a plan. And finally, it acts. It actually does something, like calling a tool or sending you a message. This perceive, reason, act cycle is what gives an agent its autonomy. And this brings us to probably the most important distinction. Think about it like this. A standard AI model is like a calculator. It's incredibly powerful, but it's a passive tool. It just sits there and waits for you to tell it what to do. An AI agent, though, is more like a personal assistant. It's an active system. It can take initiative, it can use different tools, and it can work towards a goal all by itself. So we've got the what. Now let's actually look inside and see what these things are made of. We're going to take a look at the agent's mind and body, so to speak. All right, first up, you've got the model. This is the agent's brain. It's usually a powerful large language model, an LLM, and it does all the cognitive heavy lifting, understanding what you want, planning the steps, and making the key decisions. But a brain can't do much if it can't interact with the world, right? That's where tools come in. These are the agent's hands. They're all the external programs and APIs that let the agent actually do stuff, like search the web, check a calendar, or fire off an email. And of course, to make sure this powerful system is pointed in the right direction, it needs instructions. Think of this as its compass or its North Star. This is what sets its goals, defines its personality and role, and, most importantly, sets up its safety guardrails. Now, for an agent to be truly useful, it has to remember things. And its memory isn't just one big blob. It's got layers. It has short-term memory just to keep track of the current chat. It has long-term memory to remember things about you over time, like your preferences. And it has external memory, where it can look up facts in a huge database, often using a cool technique called RAG. So you can see how this all clicks together, right? It's this constant, dynamic loop. The instructions set the mission, the model does the thinking, and the agent uses its tools to act. And then the cycle starts all over again with new information. But what happens when a task gets, really complicated? Sometimes a single agent isn't enough. That's where orchestration patterns come in. These are basically blueprints for how agents can work, either alone or as a team. Broadly speaking, you've got two main ways to set this up. You can have a single agent, where one model is the boss of everything. That's perfect for straightforward, focused tasks. But for the really complex stuff, you often want a multi-agent system. This is where you have a whole team of specialized agents working together, kind of like people in an office. So for a single agent, a really popular pattern is called REACT. It stands for reason and act. And what's so cool about this is that it forces the agent to think out loud. It literally writes down its thought process before it takes an action. This makes it so much easier for us humans to see what it's doing and why. And for multi-agent systems, I love this one because it's so intuitive. The manager-worker model. It works just like a human team. You have a manager agent that gets a big, complex goal. It breaks that goal down into smaller pieces and hands them off to specialized worker agents. Maybe one is a research expert, another is a writer. They do their jobs, report back, and the manager pulls it all together for the final product. Okay, this is all incredibly powerful stuff. But with all that autonomy, with all that power, comes a massive question of responsibility. How do we make sure we can actually trust these things to act on our behalf safely? Because let's be real, if you just let these systems run wild, the consequences can be serious. We're talking about accidentally leaking private data, misusing a powerful tool in a harmful way, or creating toxic content. The risks are absolutely there. So what's the solution? Well, it's all about building in layers of automated guardrails. These are like safety nets. You can have systems that automatically find and redact sensitive information. You can have safeguards that double-check a tool call before it's allowed to run. And of course, safety filters to block harmful stuff before anyone ever sees it. And on top of all those automated systems, you absolutely need human oversight. The driving analogy here is perfect. Human in the loop is like being a student driver. The agent has to ask for permission before every big move. Human on the loop is like using cruise control. The car is driving, but you're watching and ready to grab the wheel. And human above the loop is like reviewing the trip logs afterward for things like audits and quality check. So yeah, building that trust is a huge piece of the puzzle. But it's not the only hurdle. When you actually try to build these agents for production, you run into some serious technical challenges. Challenge number 1, and anyone who's played with these knows this one: latency, the lag. Because the powerful models that act as the agent's brain are so complex, it can take them a while to think, and that delay can make for a really clunky and frustrating experience for the user. The good news is there are some really clever strategies to fight this. You can be smart about which model you use, send simple jobs to smaller, faster models. You can also cache common answers, so you don't have to recalculate them every time. And you can even have the agent run multiple tool calls at the same time to speed things up. And then there's the big one, the one everyone talks about: hallucination. This is when an agent just makes stuff up. It states something with total confidence, but it's just plain wrong. This happens because, at their core, these models are designed to predict the next plausible word, not to be fact checkers. And that's a fundamental issue that makes this so hard to solve, and it really erodes user trust. And that really brings us full circle to the big final question we have to ask ourselves. We're getting really good at building agents that can act for us. But the much harder, much more important challenge is, how do we make sure they always act like us? How do we ensure they're aligned with our values, our goals, and our ethics? How do we bridge that final